Okay, this is our day 3 of conics. So what we're going to work on today is similar to what we were working on at the very end of day 2, which is taking an equation from, this is called general form. Okay, so we're going to take an equation from general form like this. And then we're going to use completing the square to get it in a form that we can graph it. Okay, so that's our plan. Now, what we're going to have to be able to do also is we're going to have to be able to identify conics so that you know which one you're working on, so that you know which format to get it in. So identifying conics is all about the squared terms. Okay, so what you have to get is get the squared terms on the same side of the equal sign. That's like step 1. And then step 2 is you count the squared terms. So if there's only one squared term, it turns out to be a parabola, which we did, that's back in your chapter 2 notes. If there's 2 squared terms, then there's a couple possibilities, okay? So if the squared terms have the same sign, I'm sorry, that's 2 opposite sign on the top. If the 2 squared terms have opposite sign, then it turns out that it's a hyperbola because of the minus. And if it has the same sign, then you have to see if it's like a perfect circle or if it's an ellipse. So if there's the same sign and the same number, it's a circle. So everything's the same, it makes it a circle. And if it has the same sign but a different number, then it's an ellipse. So let me show you how we're going to do that on this example, and then we'll get started. So we'll call this example 1. So you look at the squared terms. So the squared terms would be the x squared and then the y squared. So you look at those 2 terms. Now there's 2 of them. So we're over here on the right side. Now, do the numbers in the front, are they the same sign or opposite signs? I would say they're the same sign. And then the number in front of the x squared is a 1, and the number in front of the y squared is a positive 4. So we're going to say that's different numbers. So that makes this shape an ellipse. So what that means is way down here at the bottom somewhere, it's supposed to look like this with the plus in the middle, hopefully. A minus would be a hyperbola, and then equals a 1. And then there's a number here and a number here, x and y. That's my plan. So this is my goal because I know it's an ellipse. Okay. Some problems just ask you what shape it is, and then some problems ask you what shape it is, and then they also ask you to graph it. Okay, and complete the square to change the form. Okay, so what we're going to do is we're going to organize our terms like we did yesterday. Okay, so or we did last week. So you're going to organize the x's together, leave a gap, put the y's together, and then the number goes to the other side. Okay, so let me give you the steps. I'm going to give them to you in red down here. So step 1 is, I'll call it organize. So x's, y's, equals, and then the number. Okay, so x squared x, y squared y, and then the number. That's my organize. And then step 2, this one's going to be new, is you're going to GCF out the number in front of x squared and y squared. Okay, 3 is you're going to CTS, which is complete the square. So that's 1/2 of the middle number squared. And then you're going to add into the middle, well, into the parentheses. And then you're going to add, we're going to call it an appropriate value to the right side. Okay, so let me show you what that means in this problem, okay? So for this one, I'm going to do half. Well, not yet. I'm not going to do the half yet. It says to GCF the number in front of the square term. So this one doesn't have a number in the front of the square term. You could GCF out a 1 or you could just leave it. This one, it wants you to GCF out the 4 in front. So you have to figure out what was here. So positive 4 times y squared and positive 4 times negative 2y would go in there. Okay, then here, you're going to do half of 6 squared. I like to do it on the left side, but I didn't give myself enough space. So that's 3 squared, which is 9. So I'm going to put a plus 9 here. And then this looks like the one I did with the circle. So I put a plus 9 here, and I put a plus 9 here. Okay, but the second one is going to be a little bit different. So I'll complete the square over here. This is half of negative 2 squared, negative 1 squared, which is 1. I'm going to put that right here. But when I put that plus 1 there, I have a bigger effect than just a 1. It's actually, we did this with parabolas. I'm going to wiggle underline it. See that 4? That 4 is multiplied by the positive 1. So I didn't just add a 1 in. I added a 1 times the 4 in the front. So on the right side over here, okay, I'm going to have to add 4 times 1, not just plain 1. Okay. And then the next step, step 4, is factor. So let me go down here. Step 4 is factor and right with the squared. And then we'll do a step 5. So that's kind of 2 steps. So you're going to factor this one, x plus 3, x plus 3. This one you have the plus 4, and then y minus 1 equals negative 9 plus 4 is 4. And that's x plus 3 squared plus 4, y minus 1 squared equals 4. Now I need a 1 here. I need a 1. So how can I make a 4 into a 1? I could divide by 3. I'm not divide by 3. I could subtract 3, or I could divide. And what we're going to do is divide. So we're going to put divide to get 1. And that's in hyperbolas and ellipses. Okay, so I'm going to divide by this 4 over here because I need it to be a 1. Divide by 4, divide by 4. And then I get, let's see what I get. I get x plus 3 squared over 4. This one, the 4's cancel, but I like to have a number underneath, so I'm going to cancel and leave it with a 1. And then 4 divided by 4 is 1. And then this would be the answer in standard form. And then I want to graph it. So the center is negative 3, 1, opposite, opposite. The x radius is the square root of 4, which is 2. And the y radius is the square root of 1. So I'll draw a little sketch. Negative 3, 1. And then left and right 2. And up and down 1. And then that was a plus, so that was the ellipse. So that's the ellipse. You don't draw the box. Remember, the box is the one that's for the hyperbola. So there's my ellipse. And it goes up to 2, down to 0, left to negative, and then what? It went 2 over, so negative 5 now. Okay, so this is completing the square to change it into standard form. So I'll zoom out. You can take a picture of this if you wanted. And then you could check and make sure you have it all in your notes. And then the process is very similar for a hyperbola. So we'll do a hyperbola next. And the circles we did the other day, so we won't be doing a circle again today. Okay, so let me zoom out. Let me get over here. This is example 2. Then we'll also have somewhere we just identify the shapes. Okay, when you identify the shapes, they're pretty fast. I'm looking for some good ones. There's some, I think this one will work fine. Yeah, I'll do this one. Okay, 9y squared minus x squared plus 36y plus 6x plus 18 equals 0. So I modified one of the problems I'm going to give you for homework. Okay. So let's look. So we're going to organize the x's and the y's. So we can put the x over here, negative x squared plus 6x. And then let's organize the y's. 9y squared plus 36y equals, subtract 18 from both sides, and you get minus 18. Okay, step number 2, after organizing, set to GCF number in front, so factor, greatest common factor. So greatest common factor, the number in front. So we're going to take the common factor out. So this is negative 1. And then I'm going to factor out a 9 equals negative 18. So remember, when you factor out a number, you have to think what used to be there. Negative 1 times what equals negative x squared. So that's x squared. And then negative 1 times something equals positive 6x. So that's going to be negative 6x. And for this one, positive 9 times y squared is 9y squared. And positive 9 times positive 4y is 36y. Now I'm going to put a little star here on this one because this one's sign changed. And that always happens when you factor out a negative in the front. So when you factored out that negative, it just changed that middle sign. Okay, step number 2 is you have to figure out what number makes it factor to be a perfect square. And that's called completing the square. So it's 1/2 of negative 6 squared. And you want to take the sign with it. You want to make sure you take the sign with it because later on this number, this negative 3, is a shortcut for fractions. We won't be doing it that way, but when you see it in college, it'll be like that. So negative 3 squared is 9. So we're going to put a plus 9 here. Now, we put a plus 9 there, but this 9 is impacted by this negative 1. So when I add it to the other side, I'm going to add negative 1 times 9 and not just plain 9. Okay, so I'll do wiggle, wiggle, because that's what I did on that one. Okay, now on this one here, okay, we're doing half of the 4 squared, which is 2 squared, which is 4. So we're going to add a 4 in here, but that 4, I'll do a double underline. That 4 isn't really just a 4, because it's in a parenthesis, so it's affected here by the positive 9. So really what I have to add to the other side is the 9 in the front times the 4. I'm going to double underline so you can see where they came from. Okay. So you have to do the multiplication when you add it. Okay. This multiplication, and then I add it. Okay, the next step is factor. So I have to factor. You'll see that most books don't show the factoring step. They go immediately to the squared step. Okay, this is what, negative 27, so that's 9. Okay. So I like to show the factoring step to make sure it really does factor. X minus 3, x minus 3. Make sure I did everything right. So that's 9, 3, so that's right. And that's y plus 2, y plus 2. So there is a factoring step in the middle, but a lot of books, which means teachers, skip that step. And that's okay. That step can be skipped. But I like to show it. I don't like to skip steps. Equals 9. And then our last step, step 5, is divide to get 1. Oops, let me show that in another color so you can see it better. So divide. Now this one's interesting because we didn't label what it was at the beginning. I told you it was a hyperbola, but we didn't discuss why. And so to me, this kind of looks like an ellipse. But then there's this minus in the front. So that minus doesn't look normal. So in fact, we should put the positive term first and the minus second. And this is actually a hyperbola and not an ellipse. Okay, and let me show you from the beginning how we know with our new list. So first of all, you need the squared terms. So you need x squared and y squared on the same side. So that's step 1. And are my x squared and my y squared on the same side? They are. Okay, step 2 is you count how many you have. Okay, and I have 2. Okay, so 2, if they have the different sign and the same sign. Okay, so different sign is automatically a hyperbola. And the same sign has 2 categories. If it's also the same number, it's a circle. And if it has a different number, then it's an ellipse. So let's look at these 2 right here. And they do have different signs. So that makes sense then that they're a hyperbola down here at the bottom. So it's good to identify it from the beginning. Otherwise, we might have made a mistake on that one. Okay, and then I want to graph this one. Okay, so let's graph this. Let's remember how to graph hyperbolas. So the center is opposite, opposite, but you have to grab the x value of the center for the x position, and then opposite the y value, the -2 would be there. X radius is square root of what's under the x. Y radius is square root of what's under the y. So under the x is a 9, so that's a 3. And that's going to go left and right. and the y, square root of 1, which is 1, and then we're going to go up and down. I'll change to graph. No, I'll just leave it like this. So what if you don't have graph paper? Okay, so let's draw this. So 3, negative 2 is your center. I go left and right 3, up and down 1. And then usually I am so tempted to draw an ellipse, but this is going to be the box instead. So remember, you draw the rectangle like around where the ellipse would be. Okay, and then you draw asymptotes, and remember the part that leaves the box is the most important. So you have to make sure that that's long enough. Okay, the part that leaves the box. Okay, like that. And then do you remember how we tell if it's a left-right hyperbola compared to an up-down hyperbola? Do you remember how to tell the difference between those? So it's what's first. I call it what's positive because that negative sign in the middle, I think of that meaning the second one is negative. Okay, so it's the one with a positive in the front, basically. Not that it's positive too, but that it doesn't have that big minus in the middle. This minus, oops, that was an eraser, not a highlighter. Oops. Let's see. I'll just rewrite it. That's interesting. Somehow I'm on a different pen now. Okay, that sucks. Okay, so let's see if I could just do it from here. Somehow I grabbed my my screenwriter instead of my note pen. Okay, so it's the top one. That's why this is a slightly different color. So that means it goes up and down like this, and then don't go inside the ellipse box. And then you need to try to get close to the asymptote. Oh, I don't even know how I can erase here. Okay. Okay, so then you want to get close to the asymptote. So mine wasn't quite close enough. So that would be what hyperbola looks like. And I was planning to end the video soon anyway, but now I really have to because somehow I'm not on note. I'm on my pen for the screen recorder, which is kind of cool that I have that, but I don't know how to get out of it. Anyway, so I will post the homework, and then you can watch the video and do the homework in the time probably from 9:30 to 10:30 today because the video will be shorter. So it won't be a live video. It'll be this instead. Okay, so this is DL for your class. I believe this is DL7.